All right. My name's Mike. I'll be doing we're doing some mill turn today. And today's date is May 4th, 2022. So I figure it's May the 4th. Let's go ahead and do us a little lightsaber. So I got a lightsaber on here. And we're going to go machine it. Now, I was working with some strategies. I've been messing with this thing for the past day or so. And getting the right strategies has been tough. So I'm going to go add some toolpath. I think if I was to spend more time on this, I'd probably change potentially some of the paths I might use. But we're going to go through it and kind of set it up and see what we can get. And we'll try and make it as realistic as possible. But, we'll deal with it. We'll find out. So first things first, I want to start my new job. All right, so I'm going to right click here and say new job. And I'm going to use the mill turn. And I'm going to use my 1 turret 2 spindle with a Y, just so I could get into some of these areas. There is ways to do it without the Y, but it did make it a little bit more complicated. Either one, you could do it either way. We're just trying to figure out, kind of the best way. Let me go right there. Let me get my right view here. There we go. So I'm going to use the BC 1 turret 2 spindle Y, and I'm going to go right here into the stock wizard. I've already set up a tool crib for this machine, so that's one of the biggest reasons I'm going to use it. I don't feel like setting up a whole tool crib again. So I'm going to try and avoid that. For the workpiece, just going to pick the whole model right there. And that's going to be our workpiece. That represents the final finished part. And then right here, we're going to go create our stock. So I'm going to do cylindrical stock. I have my part oriented along the x-axis. That's how I like to work on mill turn parts. If you look at some of the examples inside the help system, some of them are standing vertically. So that basically your X and Z are already oriented for your part. But to me, that takes a lot more work with pulling edges off and just doing a lot of work. It becomes a bit more complicated. So I'm just going to start by doing a bounding cylinder. I'm going to tell it that the extrusion direction is in the x-axis, and then I'll tell it to calculate the stock. Now, what I want to pay attention to here is that we get a piece of stock that's actually centered on XYZ0, which means I'm going to have to make my stock a little bit bigger. So the first thing I'm going to do is right here on this XYZ coordinate for the system, I'm going to set those both to 0 so that we're centered right on XYZ0. What that shows me is that I need to make my stock a little bit bigger. I don't remember if I did 2 1/4. Let's try 2 1/2. That might have been what I used. Yeah, there we go. So we'll go a little bit bigger, and there it is. So now we have a little bit of meat on top of that, and our part is perfectly centered on the rest of it. So we'll be removing a lot of the material around here with turning. And then a lot of this stuff around this boss here, where turning won't be able to do, we'll do with either a wrapping group or we'll try a 4-axis. I tried it a few ways, so I'll show you a couple of the ways that worked out for me. And so when I'm done, I'll just hit the next or forward arrow here, and then we have to set up our origin. I always set my origin I always set my parts right here. So I always like to set my origin with this view right here, the ISO 1, because it lets me kind of look at the front face of the part nicely. And because my origin is going to be right at XYZ0, I don't actually have to change anything here. I'm just going to go in and say that my X direction is going to point towards this point here. And my Y direction is going to point towards this point right here. Now, one little tip I could give is when you're doing these, when you're setting up your origin, if you pick it the way I do, where you're just picking points, if you pick your 2 points, it should give you the right result every time. If it doesn't give you the right result, I would look at your vertex, the origin where this thing's placed. I've run into it quite a bit on my own parts, but then lately doing some mill turn stuff, there's sometimes a slight shift. So what ends up happening is I'm aligned perfectly with the front face of my part. I didn't add any extra stock. I don't really care about facing on this one. But I align it right with the front face of my part. What ends up happening is if the point that you're selecting ends up being just a little bit inside, or maybe you have some facing material, You know, you leave that face material on there, these points end up getting shifted outward a little bit. So you pick your origin at the center of the part, not accounting for the extra face that you have on there. So when you go pick those points, you're actually picking them on an angle to the origin. And if you're only leaving a 10 thousandths, 20 thousandths worth of material, I've had many times where you look at your origin, you're like, that looks fine. Everything looks that looks clean. And then you zoom in real close, or you look at it kind of a different way, and you find out it's shifted over just ever so slightly. And that can cause a lot of problems, because when you go to run your simulation or you go to set up tools for it, it's not going to have the right center of rotation. Your stock's not going to look right. If you ever open the simulation, your stock is more of a conical shape than it is a cylinder, then there's a good chance that that origin that you created is tilted, is twisted in some direction. It could be it could be twisted around Y or X or whatever. So that could cause problems. So always just make sure when you're setting up your origin, you're getting the point that aligns with these two other points. If you get a point that's inside of it, you cannot use these points to define your X and Y, because it'll put you on a weird little angle. And you'll end up getting a bunch of errors pretty much every time you try to machine, telling you that you have that whatever tool path you're doing is not for a 4-axis machine. So you get a whole bunch of stuff like that. So, all right, give me 1 second. We want to go here. All right, next step is we want to go in and define our work offset. Basically, I want to pull my part out of the rotary, or out of the spindle, so it sticks out. And I've just been going with 16 inches. This part's like almost 12 inches long, 11 and a half, 12 inches long. So I'm just going to pull it out 16 inches, and then I can go ahead and hit OK. All right, now we have our stock created. So I'm just going to blank out the stock. If you wanted to at this point, this would be a time to go set up your materials, do that whole thing. And then I also have my tool crib set up. So I'm going to right click on my milling tools. I'm going to go down to tool crib. And then I've saved it. So I'm just going to go ahead and load the tool crib. And we're going to add some tools to this anyway, because I do want to do a little face, little engraving on the face for the whole thing. So right there, give me 2 seconds right there. All right. So let's look at this. So we're starting off, and so a little bit of what I ran into was a bit from, I was going to use a CNMG, but it really doesn't squeeze down in there too much. And this is where I'm talking, we might be able to do some of this stuff. I might have to come up with some other strategies. I'll show you guys what I came up with, and you can give me your thoughts on it. I think we're going to possibly need different strategies, but these are all the tools. So I'm going to use a VNMG that's on kind of the front side of the part, on the front side of the turret, to go in and turn the main geometry down. I'm going to use that to really rough my way in and kind of get everything done. And then I also have another VNMG on the back side, so I can come back the other way and basically clean up some of the corners that I had some other bad geometry in. And then as far as other tools go, we have a 3/8 flat, which is going to do a bit of the cleanup on this guy here. I have a 16th inch wide little groove, just for a little groove that's back there. And then I have a 1/4 inch ball mill, which I'm using to go in and cut that little shape into there, so we could do our 3D cut on that. So again, may not be the perfect strategies, but you guys will see what we can do and kind of go about it. So there's a bit of geometry we need. First thing we're going to do is create a spun profile. So I'm going to add a new layer, and I'm just going to name it after the feature I'm about to use. So spun profile. And I'm just going to go up to create 2D. Right here we have spun profile. And I'm usually going to switch my tolerance to about 1/2 thou. I do that just because that's the same tolerance I use when I machine, so I might as well use the same tolerance when I'm pulling wireframe off. And I want to go along the x-axis, and my origin is at XYZ0. So I should be able to just pick the whole part and hit OK. And when I'm done, we'll cancel out. And if we turn off our CAD, we're left with all the geometry that we can machine. So yeah, that's it. I mean, we have a lot of grooves on here, and I did have some tool paths on my other part that I cut those grooves with. But the VNMG has a really steep angle on it, so we can actually get into a few of these areas. Again, maybe not the best strategy, and I might need to go with some more grooves, with more grooving. But I want to kind of make it simple for the tool path. So I'm going to start off by right-clicking on Machine Setup 1, and I'm going to go to my Turn features, and I'm going to say Lathe Turning. Now I'm going to select my geometry, and I'm going to start right here. Now this section I might do with a groove. I might do that with an end mill. You know, it's a mill turn. We got a lot of choices, but I'm not going to do this hole in the center right away. Maybe I'd need to, but I'm going to start at the front face, and then I clicked on that. No shift clicking or anything. At this point, I've just clicked on that. Now what I'm going to do is go all the way to the end of the last line here. And when I say the end of the last line, what I mean is past the midpoint of the last line. All right, so I'm going to go right here, then hold Shift and click, and it'll chain my two clicks together. So my first click on the front face, and then my back click here. Just selected all of that. And so now I'm just going to hit OK, and then hit Next. Right here we have our feature page. We have our machining strategy. Or I don't even know why I'm reading that. We got our rapid plane right here. The OD feature type, yeah, we are cutting on the OD, so that's fine. It's going to be region 1 for this one. We will use region 2. That's when we come back from the opposite direction and kind of clean up. I could tell it to cut from the stock. This is our first initial roughing pass, so I want to let it rough everything that it can. I'm even going to go add some extensions. At the start, I'll just do a little 1/4 inch or something. At the end of it, though, I want to cut off a little bit. I want to go past the end a little bit so that I have room for coming in from the opposite side and all that. So I'm just going to set the distance at the end to 1 inch, and then I can go ahead and hit Next. Now for the strategy, we are using this for just a rough. We could put a finish pass in it. Really depends. We are going to finish it again. We might as well finish it from both directions. So we're going to do our rough with the VNMG and our finish with the VNMG. So we're going to keep the same tool. And then what we'll do later on is we'll be able to copy this whole tool path and use it to cut the other side. So cut from the other direction. So might as well put the finish pass in. Posting, depending on your post, you could run separate moves or can cycles. I'm going to go with separate moves. I'm on my upper turret main spindle. And right here we get to our rough. So anytime you see a -1 as your number for your tool, it's not a tool that you've chosen. So we want to go and fix that every single time. We're going to go up to the tool crib. And for me, I'm going to go ahead and pick, it's tool number 5. It's this VNMG that's on the correct side. Tool number 1 there is the one on the back side. So I'm going to go tool number 5, hit OK. And we could show our holder. So that's what I'm looking for. I needed that steep angle. And again, this is the path that I'm not super happy with for now, but it actually works its way into a lot of these areas. I think the most important part is our depth of cut's got to be right, all that stuff. So for the patterns, we got our standard pattern with a standard sort. We could also do an offset, but I'm not a big fan of the offset too much, only because if you look at this first pass, that first pass has to take out, that's the first pass. The second pass has to take out all that material. So sometimes with the right or wrong kind of features, you can end up being very aggressive on some of your cuts until you kind of work your way into the final shape. You could also do a zigzag, which my tool's not really built for that. So I'm going to go with the standard. And for me, I'm going to use compensation on with collision detection. And I'm going to tell it to use the tool holder. So this is actually going to avoid the areas that it's not capable of cutting. And that's why we're going to come back from the other direction to clean it up afterwards. Next, we have our parameters. Depth of cut. Now, this is where for the depth of cut, I would want to set up what I'm comfortable with, especially with this being kind of an odd tool path. You'll see the results here in a minute. But I'll leave it at 50 thou for now. I'm going to overlap to the previous cut. I always like to get that little bit of a blend between the two passes. So instead of just doing no overlap and leaving a very kind of rough, bumpy surface, this two previous cuts should kind of blend those lines a little bit better with and still leave our finish allowance here. So two previous cut, I use that almost anytime I'm doing a turn feature. A lot of times when your first option is, you do a face, it's an option inside of facing, but for facing, it's not something I really need. So it's not something I'll mess with now. Just going to leave it on two previous cut. I'll go with round corners for my corner types. And I currently don't have a model that I can use to really trim the stock to. So I'm going to leave that off for now and then just hit next. Right here for the rapids, if you've seen me do lathe or mill turn before, you'll know, or any of these things. My goal when I'm going through a tool path is to change the things I know I need to change. The tool I need to pick, depth of cut, step over kind of deals. Those are the things I'm defining. When I'm working on the OD of a part, I'm really not that worried about where the rapid moves. Now, if you have a different home position, absolutely put the right home position in. But I'm not too worried about it. I'm going to use the default rapid on the approach, and I'm going to use the default rapid on the exit. That might not be right, okay? That might be the wrong answer to all of this. But as of now, I have no idea what the right answer should be, and that's a pretty good way to start. I'm going to start by going with just the defaults. If they work, great. If they don't work, I can always come back and change them. But again, I want to leave as many things as a default as I possibly can. For this one, I'll just hit next. And it's going to be the same with the leads. I don't know if a parallel lead is going to cause me any problems or an angle lead out is going to cause me any problems. So I'm going to leave it. I'm just going to hit next. For the advanced feeds, we have our convert rapids to feeds and our lead in and lead out feed rate percentages. So the percentage of your cutting feed rate used only when leading in and leading out, or converting all your G0 zeros to G01 moves, where you're then going to define the rapid feed rate essentially. That's to help with an issue called dogleg rapiding. So if it's not something you're dealing with, I wouldn't worry about it. The MDI, I have nothing happening after this operation. This is a very simple one. I could have used a one turret, one spindle because I could do most of the geometry from here and then it's just kind of a cutoff. So yeah, next. Right here for the finish pass, again, we got to go look at the tool number. It's a -1. We go up to the tool crib. We're going to go to the lathe rough here and then pick tool number 5 once again and hit OK. So there's our VNMG a second time. This one, we have our choice of how we finish it. We could either do continuous, start at the front face and go all the way back, or do an alternate where you're going to cut the turn diameters and then the face diameters. I'm just going to go with the continuous. Compensation is going to be on with collision detection using that tool holder there. And then for the parameters, this is a finish pass. I don't have really anything to clean up. It's just going to go do one pass and give us a nice clean up finish. Rapids, going to leave them. Leads, going to leave them. And the advanced feeds, no changes there. Finally, again, MDI. I'm not doing anything after or before or whatever during this operation. So I'm just going to hit compute. So it'll take a second to calculate. We'll give it time. And when this is done, the next thing I want to do is go and save. So I'm just going to do a save as. Yep, right there. We'll call this lightsaber 2 and save. So what we now can see is you can actually see the areas where the VNMG couldn't really get into. All right, so you get all that, those cuts there, and those cuts there, and that kind of stuff there. So what I want to do is I want to save the result of this, all right? Because inside of these features, whoops, right here, inside these features, if it'll open, there we go, on the parameters page, there's an option called trim to stock. But you have to apply the stock to it. So if you expand the rough or the finish, you actually get this operation stock. I don't have the operation stock right this second, but I've been wanting to try something, and I figured now's a good time to do it. So I'm going to go to my simulation. I'm going to say Start Simulation. And I'm going to let it run. We're going to see what kind of results we get. Again, the toolpath may not be something we would want to run, or we might have to do some different depth of cuts, or depending on what we're doing. But I'm just going to go in and we'll see it rough this out first. So I'll say run. Now, there's a feature in the system that I haven't gotten a chance to use too often because I don't work with STLs very often. But inside of the Create 2D tab in 34 here, we added this feature called Silhouette. And so what I want to try and do is we'll let this thing finish running. I want to save this STL as a silhouette. Or as, sorry, I want to save this stock that I have here as an STL. So I'm just going to go right over here, expand this out, and I'm going to go and save that stock. I already made some. This is a different one. So let's do Lightsaber 2. That's for my other one. I was messing with some other settings. And then I'll hit, let's do a custom resolution of, we'll go 8 thou. There we go. That should be fine. So the reason I'm using this STL is that represents my stock. Now, for those of you that are familiar with the milling side of BobCAD, and if you've ever done any saved stock for that, then you'll know that normally when you set up operational stock, you can select an STL file. The thing is, this one doesn't let you select an STL file. It wants you to just select wireframe. So what I want to try and do is I'm just going to go to File, Open, or just Open here. I'm going to turn on the STL feature, or turn on the STL file type, and I'm going to pick that Lightsaber stock. And so there it is right there. You'll see it's aligned with where it came out of the machine, kind of how the machine had it oriented. And so what I'm going to do is I'm going to take it and I'm going to rotate it so it matches what we have here. So I'm just going to go Utilities, Rotate. I'm going to take that part and I'm going to go with a Y 90. So Y positive 90. Remember the direction those arrows are pointing in, that's how you can tell which direction is going to be a positive. And so we're going that way. So we'll just say, right there's our part. I'll hit OK, and I'm going to cancel out. Now, one thing you can see is I didn't extend the stock to make it 16 inches long. The stock will be 16 inches long, but I have a little cutoff, and you can actually see I missed a little section there, probably not going back far enough. Shouldn't be a problem. Hopefully the system doesn't recognize it as a bunch of material there. But now what I'm going to do is add a new layer. And I'm going to use this as the silhouette layer. I needed to know how to spell it. So S-I-L-H-O-U-E-T-T-E. So what silhouette is used for is we're going to look at this thing from a top view, but I can go to silhouette. The problem with STL files is there's no edges on them. So we don't have the ability to extract the edges off of our STL files. So this silhouette feature allows us to do that. So the method we want is, let's leave it on enter. The direction is the Z-axis. I want to, let's say, merge all shapes. I don't really care about internals. And yeah, we'll put an arc fit on it so we get some little radiuses. Not that it matters. We're really using this for stock. So I pick my model there, and I'm just going to hit OK. And we'll wait a second. And what we'll see here is if I turn off my CAD layer there, I'm left with the wireframe that should be showing me the kind of perfectly clean version of this part. All right, so now what I have to do is I'm just going to create a line that goes right down the middle of that piece of geometry. So I'm just going to say it starts at X minus 12. That should be more than enough. And it goes to X1. That's fine. We'll hit OK and cancel out. Now, the reason I did that is because I'm just going to go to Utilities here and trim off right at the middle there. So I'll trim that. And then right here, I'm also going to trim this guy, all of these little entities, and this little guy here, and that little guy right there. And what I'll do is I'm going to join that line to there here in a second. I just want to go and trim off the end of this right here, and then that's it. So now what I can do is, actually, I think I should just be able to delete that middle line, and then I'm going to just delete the whole bottom half here. And basically, we're going to give it a new revolved shape that it's going to use. So now I can go up to Utilities. I'm going to go with the Trim Two Entities, and I'm going to join these two together like so. So just like that. So that wireframe should represent the stock fairly well. I didn't go too crazy on my tolerance with the STL because then you end up making smaller parts. But I'm going to select the geometry. I'm going to go up to home and copy. And then I'm going to go over to the lightsaber here. And I'm going to add a new layer. And this is going to be called, this is going to be op1, or yeah, op1 operation stock. I don't think we're going to be doing another operation stock, so this should be the only one we need. And I'm just going to put that there, home tab, and paste. And that's what I'm left with. And you can see it fits the shape of that toolpath almost perfectly. So now what we can do is go to our CAM tree, and you know what? There might be another way to do that. I'll show you guys one other method that might work. We'll find out. I don't know. Actually, I don't think I could do it with turning. Edit. Okay, never mind. There's not a second way I was going to do it. So now what I'm going to do, now that I have this new geometry here, I'm going to right-click on this feature lathe turning, and I'm going to say copy. I'm just going to copy it. I'll repick geometry. And then I'm just going to paste it down right there. So we need our spun profile again, and I'm just going to go in and pick the same geometry as what I had before. So I'm going to right-click on geometry, say reselect, and I'm going to go from this face here all the way back to here. And I want to make sure that my chain is going in that direction. So if you click on your profile chains, you'll see this one starting at the front face and going back. I want to reverse that thing and hit OK. Now the next change we need to make is we need to edit our feature and change this from region 1 to region 2. And this is partially going to start doing the tilt of the tool, the rotation of the tool, but I'm going to go pick the new tools anyway. I'm going to tell it that the constraints, because I've removed a lot of the material here, I just wanted to cut from the geometry. And then I'm just going to go next until I get to my roughing tool. And you'll see, once again, it does have a -1 on it. I'm going to go to the tool crib. I'm going to pick tool 1 there, which is the proper facing tool, the proper tool facing the right way, and hit OK. Now on the patterns, all the rest of the settings we're going to leave the same, except for I am going to tell it to trim to stock. I have to go define that stock, but I'm going to tell it to trim to it. All the rest of this is going to be the same. So when we get down to our finish pass, we're going to go in, pick tool number 1, hit OK. And once again, on the parameters, I'll tell it to trim to the stock. And next, really, that's it. So I'll hit finish instead of hitting compute. And this is a great time to go ahead and save the part if we wanted to. And then right here, I'm going to expand the rough and pick my operation stock. So for this, I'm going to turn that on, and I should be able to just hold shift and pick that shape, I believe. Hit OK. And then if we go and compute this, I don't think I need it on the finish pass too much, but I'll go and compute this and see if it recognizes those areas that need extra cutting versus the areas that don't need extra cutting. I may also just need a solid model. I didn't realize I could pick solids for that, so might be able to just spin that, but nope, that looks pretty decent. So if we look at our tool path, we're just going in and kind of cleaning up the areas where when we were coming from the other side, we couldn't reach. All right, so there it is, and we could go ahead and shrink these up, and I'll blank that one out, and we'll go ahead and just say save. And so just with the VNMG or the two VNMGs, one facing, both facing the ways they are, we'll see the results right here. All right, so we'll go ahead and that's running at a fine speed here. Maybe a little faster. Yeah, we'll go a little too fast. All right, so right there is where we're cutting. And those are the cuts. I don't know if we do that. I mean, maybe cut them with a little groove tool or something first. There's our finish for that side. And then we have our rough. And looks like we gouged on the back side of those teeth there on both of them. Yeah, that's not getting in there the way it was the other day. So maybe that's from that. We can remove that area. But you can see the basic shape starting to come along. And yeah, we're getting close. For now, let's think. We roughed it. Why are we gouging on that? Let's take a look. Oh yeah, that's why. Let's backplot this. It's might be our lead length, something like that. Let me where is it? Backplot right there. So I just want to get to the point where we're seeing some of these guys get cut. Wherever that happens to be, right there. So let's take a look at it. So that's why we're gouging right there. Our could be a length that's extended. Let's take a look at that. It's on the rough and the finish pass. Finish pass might be okay. All right, so let's look at our rough, say edit, and let's see what's causing that. Why is that happening over the other one? To previous cut, let's try. Why did that get reset? I saved that. I changed that setting earlier on the first toolpath, and when I copy and pasted it, it reset. I'll have to test that. That might be a problem with the system. Let's see here if this can get us out of there or not, or if it's going to just gouge that thing again. Nope, still gouging. Why is that? Is that my leads? Let's try the leads. All right, so I got a parallel lead in, an angled lead out. Let's do a 25 thou, and then we'll angle out. Let's see. I don't know if that's what's causing it or not. Yesterday, I'll show you guys the one I was working on yesterday and a little bit today between my trainings that I was doing. I didn't do the stock that way. Ooh, that looks a lot better. Let's just backplot that real quick. Get into where they start happening. There they are. So we'll see. Yeah, we're going to clip that corner right there with the holder, as you can see. So 25 thou still a little bit not enough. Really, though, where's my finish pass? Why did that not calculate? What in the world? I didn't change anything on this, really, did I? Oh, no, let's not trim to stock on the finish. Okay. All right, and the last thing I'm going to change, I'm going to make this 15 thou. All right, here we go. Compute that. Yeah, the way I did this yesterday was I didn't do the operation stock, so it just kind of reran. And then the way I set it up was with that on that first page of the toolpath, you have your, what's it called? It's right here, the feature page. So what I did before the first one, we always, pretty much your first toolpath, you're always going to run from stock. Your facing pass, if you do a facing pass first, that's usually going to be run from stock. And then your first initial kind of turn rough, turn finish deal that you're doing, that's going to usually be from stock as well. But now that we've removed a lot of that geometry, the way I did it yesterday was I just used from geometry. And so I end up cutting a lot more. I'll show you that example. So there is a difference between kind of my initial thoughts and then how we're doing it now. So, kind of going on the fly here. But here it is yesterday. That's the rough for that. So I ended up cutting a lot of the same areas. But by doing that, I didn't have any of the gouges. You could see it kind of avoids the gouges. But this one looks promising here. The finish pass is going in. Hopefully not clipping anything. Let's do our start simulation. I'm just going to fast forward through the whole thing very quickly. All right, using the progress bar down on the bottom. So just going to take this progress bar, slide it all the way across, wait for it, and we're going to take a look at it. There we go. Looks all right. Looks like we could clean up the insides of those a little bit, maybe with a little grooving tool or something, because you could also do every one of those as a groove. We could do every single one of those as a groove. You'd have to get the specific grooving tool, because I do have flats on the bottom because I can't get all the way to those points. There it is. So that's our overall kind of OD to the part. And then if we turn our CAD on, we can see now it's time to start doing some of this. We got one little thing we'll do. We'll go and clean up. We'll go and clean up the groove real fast. This little guy right back here. So with that groove, I'm just going to right click, go down to lathe features, or sorry, turn features, lathe groove, select the geometry. I'm just going to pick those three sides of it. If you need to, and sometimes you do, you could also go and pick these ones. That way it recognizes that there's a wall here and we'll kind of offset from that. It should be fine. We're going to try it this way first. But once in a while, you'll have to potentially pick geometry like that. I'm going to go from the geometry of my groove so it doesn't waste a bunch of time trying to cut a bunch of air. It's an OD groove. Yeah, region 1. For the machining strategy, this one really probably only needs a finish pass because we are using the VNMG is getting into that groove just a little bit. But I'll do a rough and a finish. We'll go ahead and pick our tool. I got the 16th inch wide here because it is I think that groove width right there is like 113 thousandths. It's not much. So got a 16th. For the patterns, going to go with a standard cut and a standard sort. This is also like a single pass, maybe for those grooves, right? Those other grooves that we had down there, the pointy ones, you have a tool that fits that shape. You can actually do it as a single pass and just have it kind of plunge in, cut the groove, and move to the next one. I am going to collision check using my tool holder, just in case I accidentally pick the tool where the length of the holder, the length of this right here, if that ends up being too short, by using this use tool holder, it will adjust and make the grooving tool only cut what it's capable of reaching. So if it didn't have the reach, it's not going to cut it. All right, parameters, got our 1/2 thou for our step over. We'll use the 10 thou allowance there. I'm not going to do multiple depths. This is a real tiny groove anyway. Rapids, no changes. Leads, going to go with the defaults. It's parallels, the only one for the rough anyway. Advanced feeds, no changes. And MDI, no changes. So right here, we got to go pick the same grooving tool. So tool crib, tool 3, hit OK. For the patterns, I'm going to just I'll do a basic finish. I'm just going to run it one way instead of meeting in the middle. It's a small groove. And I'm going to do on with collision detection, again, using the tool holder. So if I did accidentally pick a tool that has too short of a stick out for the groove, for the grooving insert, then this will adjust it and make it cut as much as it can without crashing that holder. Parameters, it's a finish pass. We're going to 0. And then we get to the rapids, no changes. Leads, just going to try the defaults. Advanced feeds, no changes. And finally, the MDI. Now, when we're all done, we can go ahead and hit compute. And it's just going to calculate that groove real quick. Should be a pretty quick one. Yeah, there it is. There's our little groove. And I'll give it a save. All right, so now we can turn our model back on. And that's everything that we need to worry about for turning. All right, so now I'm going to go to an isometric 2 view, this one right here, or it's on the list right there. The shortcut for ISO 2 is Control 7. And then I've also gone in and set up a shortcut for this one, this ISO 1. For me, that's Control 9, but I had to make that one. So if you ever want to make a shortcut, you go up to your settings, go down to Customize Shortcuts. If I scroll down, I can go to ISO 1 right here and add a new keyboard shortcut. And Control 9 is not used by anything in BobCAD. Control 1 through 8 is for a bunch of different views, but Control 9's not. If you get a lot of SolidWorks files, I found that the isometric view that they use as their default is this Control 9 one. It's this ISO 1. We use ISO 2 for the most part because we're looking at kind of the X and the Y and the Z right here. But there it is. Let's blank that out. All right, so let's go ahead and give this a shot. We're going to take this right here, and we are going to extract the edges off of it. I'm going to pull the wireframe off of it. And there's a bit we have to do with this. So I'm going to start here, and I'm going to do it on a top plane, but I may be better off doing it on a front plane. I'm going to do it on the top plane first, and then we'll probably end up rotating it. But I'm just going to add a new layer. And I'm going to call this my unwrap pocket. All right. And the first thing I want to do now, unwrap, when you go into it, it does have a feature for automatically defining kind of where it needs to run, which could probably work. Actually, it's working pretty good. So I'm going to pick that, and I'm going to pick this bottom side. And then right here, so you get these weird results sometimes. I know I've worked with some of you guys and we've dealt with this stuff. If we uncheck this chaining selected geometry option, it cleans it up quite a bit nicer, as you can see right there. So what we have to do is really just kind of close off the edge and then delete these two lines, because those are the split lines from the surface. And then that will be this big boss that we're trying to machine around. So I'm just going to go ahead and hit OK and cancel out. And then I'll turn off my CAD. Now, the problem I'm going to run into is I don't have, I'm using I think I set up for a 3/8 tool. I don't have that much space right here. Those lines are not, there's not 3/8 there. So what I'm going to do is I'm going to start off by just deleting this and this. Just delete those two. And then in my, in this feature here, I'm going to close off the geometry. So I'm just going to close this from here over to here. So we have just a closed shape. Now, what I want to do is on one of these sides on the long ends, I want to go a little bit further out. I want to extend that one out. I also want to extend out the sides. We're going to use a 2-axis toolpath for this. So I'm not worried about it seeing this geometry and trying to cut into that groove or drop down here and machine anything over there. Because of this being wireframe or being a 2-axis, we'll be able to tell it how deep we want to cut. So I'm just going to go up to the Create 2D and Line tab, and I'm going to just do line parallels. Now I have a 3/8 tool. I'm just going to use 3/8 as my value for my distance, and I'm going to move this left side line over. This side didn't go the right way. This guy is going to move over. Okay, that's good, I guess. That one's going to move over. That one's going to move over, and then I'll have this one come out. So this extended piece here is essentially like saying we want to go past the meetup point. I want to go past where these surfaces end and kind of blend between them so we don't miss anything. And so now I'm going to delete this, 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 and this. And then before I go and rejoin everything back together, notice I have broken lines. I'm going to try and go to Utilities and just do a cleanup optimize and see if I can clean up that geometry, which it looks like it did, as you can see. So now we have that. So now we'll use the Utilities, trim 2 entities, and just extend all this. Open pocketing doesn't work as far as I know for 4-axis. Otherwise, maybe we could have just done some dotted lines, but shouldn't work that way. So now we can go in and do our mill features. And I'm going to go ahead and do a, well, before we do our mill features, I apologize. I have to go and set up a wrapping group because we unwrapped our geometry. So I'm going to go right here to Additional Functions, add a wrapping group. The geometry that we're working with is not wrapped, but I don't remember the diameter and it didn't take it. So I'm just going to turn on the model, go to Evaluate, Measure 1. We're going to go ahead and pick that, that arc right there. And that's going to give me the diameter, 1.4961. So now I'm going to go in, edit the wrapping group, set the wrapping diameter to 1.4961, and hit OK. Now the next step, and this is the thing that I always forget myself, and you guys may as well. I don't know if you're doing any wrapping with mill turn. Your wrapping geometry that you create has to align with or kind of point towards your x-axis here. Because you got to think the tool that we're going to be using is coming in line with that x-axis. So I want to be able to come in and machine that pocket around there. So what I need to do is take this geometry and rotate it 90 degrees. So I'm just going to go Utilities, Rotate. I'm going to hold Shift and pick the inside shape and the outside shape here. And from the center, I'm just going to go with an X. It's going to be a minus 90 here. So it's going to be sitting just like that. So X is going to be minus 90 or 270, either way. Hit OK, cancel out, and you can see what it's doing. Now, one of the problems we might have is this could end up in the wrong position because of that rotate. It might actually end up on the bottom of the part when we watch it in the simulation. Yesterday, when I was messing with this thing, I ended up doing all my unwrapping right here, and the whole part was actually standing up vertically. So I actually, when I rotated my geometry like I just did, I actually ended up rotating the part and the geometry together. So again, we might have a little bit of an off cut right here. But if that's the case, what we can do is shift this geometry up. Actually take this geometry and find out what basically I think a quarter of it, and we can move it up. I'm thinking we'll be 90 degrees off on this. That's what I'm thinking. So to find out, let's go ahead and do our tool path real quick. I'm going to do just a mill 2 axis, select geometry. Now you'll know you got it in the right position when you pick the geometry and it shows you the proper distances there. I've had other times when I go to do this and I didn't, one of the big signs is, let me restart this. I've had this happen many times where I go to pick the geometry and it shows up as just a single line with a, half-inch depth or whatever. But really what's happening there is that's happening because my geometry is not oriented to the correct axis. You want this stuff sitting perpendicular to your tools that are sticking out of the turret. So that's how we're going to set it up. We got our 2 different chains there. Don't really care about the leads right now or start points so much. We'll put our start point in the middle there. The top of the feature is going to be off of this surface here. So we're going to go right there. The bottom of the surface, we're going to go to right here. So that should be our depth. So 4562, we'll hit OK. Next. So we got our top of feature and our total depth. That's all fine. Right here, we're going to go with pocketing, which gives us a pocket and a little finish pass. We're going to use we're not leaving tabs. For posting, just going to double check everything. Got work offset 1, main turret upper turret main spindle. The multi-axis posting, no changes there. The pocket. So now I have to go up to the tool crib and make sure to pick that 3/8 tool that I got right there. So I'm going to pick that, hit OK, and then go next. Now for the pocket, I'm going to go with an advanced pocket. I'll do we'll do just an offset pocket out. Step over, I'll go something like 25%. No reason to be crazy. Right here, we get to our parameters. So yeah, I am going to leave 15 thousandths for the finish tool to clean up. And I am going to do this in multiple steps. I'll say let's do 0.4562. We'll do it in 4 passes. So just to work our way down there. For the leads, no changes. I'm going to leave it on plunge. Machine sequencing, it's only 1 pocket, but I usually just turn on optimize just because. Next, again, we have our links, no changes. Advanced feeds, no real changes there. Again, a lot of the settings that we're going through, I'm intentionally kind of ignoring because I don't really need them. There's my 3/8, okay. And right here, we got our compensation. Parameters, we'll go full depth this time. Leads, we could play with some leads potentially. I'm not going to do anything right now. And that's really it. All right, so I'm going to say finish first just so I can say save. And we should see it because on our wrapping group, when we edit this, our geometry is not wrapped, which is we've flattened it, but the toolpath is going to show as wrapped. So I'm going to go ahead and compute this thing. And we'll see there it is. Now what you'll see is in this area here, that's where that pocket is supposed to be. That's where we're actually going to be cutting this thing off according to how it's sitting now. So what I want to do, and this is a test I haven't done before. I'm going to go to evaluate and measure 1, and I'm going to grab that line right there. And I just want to find out how long it is. It's 5. Let me move this down a little bit. 5.075. So I'm just going to pull up my calculator, wherever I put it. There it is. And I'm going to say 5.075, and I'm going to divide it by 4. And so what I want to try, just as a shot in the dark, we're going to take this value right here, the 126.875. I'm going to just copy that. And I'm going to translate this geometry up that distance. So I'm just going to go utilities and translate. I'm going to use that value. I copied it a second ago, so I'll just paste it in there. And then I'm just going to go ahead and pick that and that for the geometry. Oh, went the wrong way. Let me put that there. We got to go in the Z. I apologize. Right there. So that's going to shift it up so that it's centered on that, I believe. Oh, no, we have a little bit of length left. I added geometry onto it. I added what? A quarter? What did I do? 3/8? I added 3/8 onto that end. Let me try this one more time. Let me do some math, a little bit different. 5.075 minus the 3/8 I added, and then we divide that by 4. So let's say 1.175 and see what that gives us. So Y is going to be, or Z is going to be 1.175, and I'm just going to pick those two. And that looks a lot better. You can see that that rectangle aligns perfectly around there for us. And so I'll hit OK, cancel out. And then on my CAM tree, I'm going to right click on the word geometry and say reselect. It's going to learn its new position, and I'm just going to hit OK. And yeah, now we should be able to compute that tool path. And if we look at it, we now have that gap right there. Now, one thing I'm noticing, we don't have our finish pass. Our finish pass is on the wrong side, I believe. Let's, maybe not. What is it doing there? Oh, that's our full finish on that. Maybe not. I guess it is doing some finishing. That should be fine. Whoops. That should be fine. Let's go ahead and save this thing and post it. Now, yesterday when I was running into this, I worked on this one for a minute trying to get a good finish out of here. So we might have to, we're going to come back and kind of remachine it. I tried using the 4-axis rotary advanced rough and finish. That gave me some decent results. But what you'll see here is it leaves these big kind of angles on the part that we have to take care of afterwards. So right here, I'm just going to fast forward down to our pocket. And then run. So you'll see it is treating it kind of like you would a pocket, you know, just a wrapped up pocket. Excuse me. And we're getting nice clean cuts on the edges, mostly because of that, what you call it? The, man, I can't remember what it's called. Oh, the overlap we did where I extended everything out by 3/8. So that's why we're able to get over those edges and get a nice clean finish on those ones. So I'll just speed this up a bit. And then, yeah, that's, I believe, where it's at. Right there. And yeah, so it's just going to do that. Let's speed it up a bit. And on here, I'm going to turn my workpiece on so that we can see what's really left over when we're done. So the pocket comes out, that big pocket we did comes out looking great. The problem is, let me turn this stupid thing off. There we go. The problem is if we look at this right here, it left all that material on there. So the first way I tried to do it was I used this top surface as an index, and I think we're going to do it that way again. I'm going to use this top surface as an index so that when I call out, you know, this index, that wall should be kind of straight. Maybe we'll just use a ball mill to clean up that bottom, which I may or may not have. I might have I can't remember if I got a ball. I think I got a 1/4-inch ball mill in here. So now what I'm going to do is we're just going to go do our, what you call it, I don't even need a layer, an index. So we're just going to right click. We'll go down to our additional functions and add an index. From there, I'm just going to go ahead and pick the top surface there. It knows what axis to come in from, and I'll hit OK. Now, I'm then going to right click on that index system and do a mill 2 axis. We could potentially do a mill 3 axis. We'll see, you know, we'll play it by ear. Really, I'm just going to go from there to there. I want the bottom of the job to be down to there. And yeah, there it is. We could check our directions of cuts. We want to make sure we're compensating to the left for everything. So I want to make sure to the left puts me on the correct side. And you'll see both of these are backwards. So I'm just going to reverse all directions. So now to the left of either of these chain directions will put us, on the outside of the wall where we need to be. And so we'll hit OK. From here, I'll just go next. No real changes there for the feature. Next again. For the strategy, I'm going to go with just profiling, which gives me a profile rough and a profile finish. Next again, no real changes till we get to here. And here's where I'm going to go and pick my, I believe, 1/4-inch tool. It's the cross mill, 1/4-inch ball mill. There we go. Cool. That'll work. Hit OK. Go next. For the patterns, couple options here. I'm going to try this side roughing out. Hopefully side roughing will let me step away from there because we do have a pretty decent size angle. So I'm going to say let's do stock remaining at 3/8 of an inch, we'll say, and I want to do it in 3 passes. Compensation's all fine. Parameters, we'll leave 15 thousandths, but we are going to do multiple steps. We're going to do this 0.5912. We'll divide it by 4. I mean, that's good enough. Maybe a little lower if I wanted to be a little safer, but I'm not too worried about it. Any of these values can be changed, so there's always that. I'm going to do a parallel lead in, so I could start kind of over here and get through and make our depth cut, or make our cut. 1/4-inch will be fine. Corner types, no changes. This is a standard 2-axis toolpath. We're just using it on an index, so we're just using a feature that's going to call out on an index, so it's pretty easy. And then we can, that's our 1/4-inch. Yep, so we'll use the same 1/4-inch tool for finishing. You could apply G41 comp at this point if you wanted. Other than that, I'm really just going to go with parallel leads, and that's it. So we'll hit finish. I'm just going to give it a save just in case, and then I'll go and compute that. And we always want to look and make sure it's doing the right thing. So this should add a little radius into the corner. The biggest area we might have some problems is right at that corner, kind of just past where the radius is going to finish. There might be a little bit of meat left right there that's not perfectly clean, but we'll take a look at it in the simulation. Overall, that one looks all right. So we'll give that a save. And then, yeah. So now what I want to do using the same index system, because it's aligned with the same, same view here, I want to go in and I just want to machine this little area here. The problem is before I can go and do that, I have some odd surfaces that I have to deal with. When I got this model, what you'll see is this floor that's here actually connects all the way around. So I can't just go and pick the area I want to machine. I have to pick the area I want to machine, or I have to pick the whole part as the geometry, and then I have to give it a boundary to use. So what I'm going to do is I'm going to go to a front plane. All right, now my front plane is cutting the part directly in half, but that front plane aligns with this side right here. They're parallel to each other. So I'm just going to go and set we got our front plane. I'm going to go to Create 2D, Extract Edges, and I'm going to project to the Z plane. I'm going to project to, I'll just say Z1. All right, so I will pick, or no, let's go Z-1. There we go. And then I'm just going to go in and pick the surfaces that kind of align with this. So that one, that one, that one, and that one. And then I'll hit OK, and it'll flatten that all out. So now if well, hold on, let me do this. Let's add a new layer, call it boundary. Boundary, and try that again. So I'm going to make it a little easier on myself. There to there, 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 and there. I'm just going to hit OK. And then I'll just go and close out I'll hide the CAD. And then all I got to do is join a line across these right here to right here. Now, the reason I can't use the boundary directly off the model is because I'd have to connect somehow right there. So I'm making my own boundary here. It might need to be a little bit bigger, but I'm not too worried about it. So let's go ahead and get this to work right there and right there. And so when we go back to a top view, again, that boundary that I drew is aligned not only with the index, but with the x-axis. Not with the x-axis, but with the tools that are going to be used on that x-axis. So that's what I got. So with that same index, we're going to try this out. We're going to right-click on Index System, 1 or whatever, just index system. Mill 3-axis. For our geometry, it's always the whole part, every single time. For the boundary, I'm just going to go ahead and pick right there. And I'm just going to hit OK. And we'll go next. We don't get any previews here. Machining strategy. I'm going to go with, I'll use a little advanced rough, and I'm just going to use this to just take out a little bit of the material that's in there, not too much. And then you have a choice. I mean, a Z-level finish could potentially work. I'm going to go with just the advanced planar. So the advanced rough, the advanced planar. Honestly, you could probably get away with just a standard planar as well. But I'll use the advanced one. So our roughing tool, I'm going to use the 3/8 flat. And I'm not going to be too crazy with this. We're going to go with 3-axis. I'm not doing any 3+2 or anything on this. Offset pocket out, sure. The depth of cut and the step over, I want it to get in there a little bit, so I'll go 50 and 50, just so it has a couple passes that it could do to remove some of that material. Leads, just going to plunge in. Options, nothing really to set up here. Just kind of next my way through, nothing that sticks out. So yeah, none of the settings really needed for that. Now we're going to use our finish tool, which is our 1/4-inch ball. And this will be a 3-axis. It's not, we don't have to mention that we shouldn't have to do anything for the fact that it's 4-axis. We should be 3-axis because this is on an index system. So the lace angle, I'll leave it at 90. So that's going to go along the Y-axis when it cuts. Step over amount, I'm going to go, let's say 10 thou. I want a nice clean finish there. Leads, don't really care. Options, nothing really to change other than usually if I see 3D extents, I turn it on. Links, no real changes. Gouge check, no real changes. Advanced feeds, no real changes. And MDI, no changes. This one's a 3-axis toolpath. It will take a little bit longer to calculate. So what I'm going to do is finish this, save it, then I'll go calculate it. I'm just trying to save myself the time. If something happens, I don't really have to concern myself with it. So there it is, little finish there. If we look at it, let's blank that thing out. Let's blank everything out. So here's my advanced rough. There is a lot of material missing from here. Part of it could be handled by right here. If I go to the parameters page for the toolpath, I can define the top of job as this right here and hit OK. And so what that'll actually give me when I recompute this, I'll just hit compute, is a shorter set of rapids on there, a shorter set of cuts. So now it's going to be kind of just working in there. And even that's more than we really need. I really could start at the top of this, but I'll cut a little bit of air. And then there's our little planar toolpath, just like that. So before we go and simulate it, though, I want to make all of those. I want to do all of those cuts. So I have to, but I'm lazy. And I don't want to have to go in and set up an index system for every single one of those because it's a lot of work and you have to know your angles. Not that it's difficult to figure out, but I could also go in and do a toolpath pattern. And before I make a toolpath pattern around a 4-axis or around a rotary, I need a line down the middle of the geometry. So what I'm going to do is just make a line. That is x minus 12. And it goes to x1 right there. And what we're using this line for is for the toolpath pattern, it's going to tell it what line to revolve or what line to rotate all these toolpaths around. So I can hit OK, cancel out, and then I'm going to right click on the feature 3-axis here and add a toolpath pattern. Now the pattern is going to be a rotate, and then I'll hit next. We have to make sure to turn on this 3D option. There is 6 of those around there, so my angle is going to be 360 divided by 6. I have 1 programmed already, so my copies is going to be 6 minus the 1, so 5. And then right here's where we pick our rotation axis. So I could go in here and say it's right on the end here. I'll just pick the end point for that one and hit OK. And then I'll pick the end point for the other side right here and hit OK. And then I'm just going to hit OK. And so if we see that, look at that. Now we have all of them getting cut, just like that. And it's all the same tool path. It's just a 60-degree rotation between each of them. So once again, we'll give that a save. And let's see where we're at so far. I still haven't checked out what that thing's going to look like, so I'm interested. I'll turn the machine on so we can get a view of it. Let's hide the workpiece. What's the fixture right now? Oh, that's that. Okay, I'll leave the fixture on. There we go. All right, so here's our turns. Little collisions there. We come back the other way. Cut our groove, and then our pocket. This one takes a little while. A lot of stuff going on here. And slow it down. Not that low. All right, there's a little finish to that. Not that we even need it because it's not finishing nothing, but oh, we got tools being used together. So there's our 3/8 little rougher for the back pieces. I have to go to the machining order and set it better. Let me turn this off so we can see the part getting cut. So you can see it's, you know, putting that little flat in there all the way around. And then I believe, looking at this, we should go, yeah, then we're going to go do our advanced or our profile rough. So then it's going to go from doing all the roughing with the 3/8. It's going to switch to our 1/4 inch ball. Should do this first, and then it's going to come back and clean those up. So I'm okay with that. So this should be the last one right here. And then we get into our 1/4 inch ball. And I don't know how this is going to look. It may not look great, but we're going to run it down there. That's what I was worried about with that ball that we got. That's about as good as we're going to get unless we were to drop it a little further or use a smaller ball. Actually, not too shabby there. I don't hate it. And then the ball goes in and does the planar. And when you're watching your simulation run, don't look at the quality of it right now. You want to focus on the quality at the end of the job. A lot of this stuff will get cleaned up when it's all done. Like all this jaggedness for that groove. As soon as it finishes, you'll see a cleanup pass be running. So right there. Yeah, and then this should be the last one. And then again, now it's going to kind of clean up so you can see the groove. And there is those little cuts there. And if we take a look at it, not too bad so far. It's definitely, other than, actually, honestly, this is better than what I was getting yesterday right here, which is saying not much, honestly. I'd want to go a little tighter to that. It's a tough one, though, because I'd have to go with a smaller tool. Possibly if we went with like a straighter tool, we could get in there, but then I risk potential gouges. I'll have to look at that a bit more, kind of find out what's the best way of doing it. Other thing is this little top thing right here, this little guy right here. I didn't face that off yet. I didn't clean that up yet, so I need to do that. And yeah, so we're gonna do this. Add a layer. Let's call this, index facing. And I'm just going to, yeah, right there. I'm going to just pull the wireframe off this. So I'm going to go again to create 2D, extract edges, and I am, let's see, that's projecting to X or Z minus 1. I want to go to, that's Z minus 1. I'll go Z minus 1 point, Z minus 1.5. Let's see if that gets us up above. Yeah, that's perfect. Okay, so I'm just going to pick all that like so. And then if I hide all the rest of this stuff, we're left with a bunch of geometry. Whoops. We're left with a bunch of geometry that looks like so. So now what I'm going to do is go and delete pretty much this whole bottom half, or pretty much that minus the 2 lines and 2 of these, just that one and that one. And I'll delete all the rest. Now I'm going to go up to utilities and trim 2 entities, and I'm going to extend those to meet each other. So I've basically just given myself a little rectangle that I'm going to use to face off the geometry on that right there. So I have to go in, I'm going to right click, I'm going to do a mill feature. Now there is a mill facing, but this one's looking specifically at the stock, which could cause us problems. I want to go and say mill 2 axis, pick my geometry. So I'm going to pick it right there. And my origin, the top of it's right here. I do have a little bit of meat on there though. Wait, what's going on here? Oh, I forgot to, hold on. I got to right click on my index system. All right, so we'll do a mill 2 axis, select my geometry. So again, this will show it better. So there it is. Top of part is at 0.0991. That's how much is sitting on top of that. So all I'm going to be taking off is we'll say, well, actually, I'll just say pick bottom and pick right there. And it should be the same value. So we'll pick that, hit next. Next again, right here we can choose facing. So facing isn't just a toolpath by itself. It is available in the 2 axis as well, which I like because it gives me more control over it. I don't have a big tool for this. I'm just going to use I'll just use my 3/8 and kind of clean it up. We'll go off the part by half the tool. We'll zigzag. We'll do a 40% step over, we'll say. Parameters, no changes there. We'll do the full amount in one shot. Leads, I usually put a lead on and I make it half the tool, at least, whatever the radius of the tool is. Links, not going to change that. Feed rates, don't care. And then I'm going to hit compute. And there's our quick little facing pass on that. So now what we can do, and let's try something here. This might give us this corner potentially better. Let's see. So I want to go in and, I want to do another index. So I'm going to right click here. I'm going to do an additional function. I'm going to say add index. And this index is going to be off that face right there. If this works, we're going to have one on the other side as well. But basically, I want to use which toolpath? This toolpath, I believe. The 1/4-inch ball right there. I want to use that one. I'm going to copy that toolpath. I'm going to paste it under this index system. And for my geometry here, I'm going to reselect. I'm going to pick this edge right here. So the tool is going to come in right there. It's going to be offset a little bit. I'll say, why is the top there? So the top I'll say is this right here. That's 0. So let's go 0.5. And the total depth I'm going to go is 0.5. And I just want to see if this works. Hit that, and then I'll go and compute the tool path. We have to reverse the direction, I believe, and then compute the tool path again. So there it is. And then I'm going to get rid of the extra. I'm going to be slicing through those little buttons. Whatever, those buttons will be different anyway. I'll make them pockets or something. I don't care. I'm not going to do a side rough. Just the one pass. That should be offset. I don't know. Let me see. Let's think here. I'm trying to think of how we might be getting that cleaner right there, but I got no real great ideas off the top of my head. Let's save it and see what this does first. What I'm thinking we might, I don't know. We shouldn't gouge it, but I don't know if it's going to clean it up as nicely as I want it to be cleaned up. So let's just take a look. We'll find out, won't we? We're on this May the 4th journey together. All right, machine. I have no idea which tool path it is. Oh, it should be the last one. Right there. So no errors loading the simulation, which is fantastic. Let's say run, and that should rotate. Okay. You son of a gun. Couldn't even see it. All right, so there it is. Meh. Kind of didn't do anything there. Yeah, it was a shot in the dark because we're offsetting off that edge. What I may be able to do is just to get kind of weird with it. If I was to put a negative, well, I'll leave that. You know, I'll just, I don't even need the profile. Okay, great. Just do your thing. I'm going to get rid of the profile rough and just leave the finish. What I could do is put a negative allowance, negative, let's do 50 thousandths first, just to give it something. And it's probably way too much, but this could be an idea on potentially getting a little closer into there. Basically, I'm kind of lying about the tool. I'm using a negative allowance, so it's saying that the tool's only 200 thousandths wide, which might potentially get me into that area a little bit better. Maybe too much. We'll have to find out. But we'll go ahead and get down to right there. And yeah, we'll let it run. And then holy cow, that was beautiful. That looks pretty decent now for just guessing a number. That wasn't too bad. Now it's a little, it's got a little divot there. I went 50 thou on that. We might be able to go a little less, but honestly, that would be totally fine with me. I'm not trying to make these for real. Lightsabers aren't real, so this is just a collectible item for myself. That's actually not too bad. Looking at it, we could maybe back it off a little bit. Maybe go for like 45 thou instead of 50, 40 thou, whatever it is. But I'm happy with that for now. I'm going to go do this side, same exact tool path. All we got to do is make a new index. So I'm just going to add an index. This one's on this side right here. And I'll hit OK. And one thing that I'll be honest, I didn't draw this thing. I found it online. It's not too outrageous of a drawing to do now that I'm looking at everything. It's really not too bad to draw, but I found it online because I didn't need to draw it. But if I was drawing this and I did this all myself, I would try and put a little fillet on there just so you have a little blend, a little bit better. Having a sharp corner on a round part, and it's just a difficult cut to make. Potentially. So now I can take the feature 2 axis. I'm going to copy it. I'm going to go ahead and paste that feature. It should ask me if I want to use the same top and depth. Yes, I do. For the geometry, I'm just going to pick that edge right there. I'm going to hit OK, and then I'm going to compute it because the direction might be wrong, but it is not. That looks good. Are we going to clip over there at all? No, we should be fine. All right, so let's think. Is there anything major that I'm missing? I'm going to go and do the one last, a tool path I know I'm going to need eventually, but I might as well just knock it out real quick, which is going to be the cutoff. So I'm just going to do a quick cutoff on here. I haven't mounted this tool, so let's just do a lathe cutoff. Geometry is going to go right to there. Okay. And then for my machining strategy, it's just going to be a cutoff. Again, I haven't mounted this tool yet, so I got to go to the tool crib. I've been doing all my even numbers are milling positions on this machine, so all my odd numbers will be turns. So I'll add an adapter. We're going to add a side mount turning X adapter. I'm going to mount it to the side face, so there it is. And then if you guys didn't know it, whenever you create a tool that shows up as a loose tool, you can actually just grab it and drag it onto your holders after you place them. You just have to remember to go apply your shift. So I'm going to put a -3 for the shift to pull that out of the holder, hit OK, and then this is our cutoff. So right there's all our numbers. Great. Looks good. Hit compute. Quick cutoff. All right, so we'll give that a save. And yeah, let's check out the whole thing right quick. If you guys have any questions at any point, by the way, feel free to ask. This is one of those, just kind of going through it, kind of experiencing what I figure you guys run into when you're using this, because there's no perfect answer to what toolpath you're going to use all the time. So sometimes you have a fight with it. Now, honestly, this is going a bit smoother than it was for me yesterday. I was having a lot of gouges and stuff. I had a bunch of different routines too that I was working on. See, collision between flute and stock. I got to put better leads on it. Flutes. I'm missing so much of it though. All right, so this is where we start taking down the milling stuff. And the last thing we're going to do here to finish up, I got to go create the geometry still, but I want to go in and create some text around that front face that we, right around this little guy here. And we're going to do some text that kind of cuts around there and engrave it in and see what we get. So we're going to continue this. Yeah, a little faster there. Get a drink. All right. I'm interested to see how this thing all comes out. There's the one. There's our planars. Right there. I want to go too fast because I don't want to miss the little bits that we got at the end here, because they are quick. There was our cutoff. What happened with the cutoff there? Fast forward right to the cutoff. Come on. Oh, come on. There we go. Oh, I got the wrong cutoff tool. Yeah, I accidentally picked a grooving tool. Huh, that makes sense. All right, so let me change this tool. Change tool. Yes. And I want to choose my cutoff. There we go. I got a longer cutoff right there. Much better. Okay, hit it. All right, that's a lot better. So that'll do our cutoff. All right, so I'm not worried about the cutoff. That was fine. So now what I'm going to do is I'm going to switch to a side plane UCS right here, so that I can draw right around that face right there. And we'll put this in there where it's going to fit. I still have to put the tool in and everything. But let's go do this. Let's just call this layer text. And what I'm going to do is I'm going to extract the edges from this right here, from that surface and that right there. So both of them. So I kind of know what I have to fit my text into. I actually don't need that one if I'm picking the other one. So we'll just pick that surface. And I am going to project it to Z0 right there. So I have just the face. Okay. So now that I can look on this CAD, and let me go to a view here. We're going to go right there. By the way, if you guys didn't know, this is new to, might have been 33. This button right down here is views to active UCS. If that button is not turned on, when I go and click a top view, it's going to show me the top view of what the top UCS uses. If I turn that button on and I go to a top view, it'll align with the axis that's set up. And all your views will be according to that. So I have a top, I have a front, I have all the different views I can use. So now I'm going to go in and we're going to do some text. So before I do text, let me check out these arcs. That looks good. Okay, so I'm thinking I'm going to use this little guy. We'll find out. We'll see what it fits around. So I'm going to go into text, BobCAD font. We'll do a BobCAD font. I'm going to use the Helve one here. Now, you could get fancier with this. You could probably go online, since this is a lightsaber. You could probably go online and find yourself some text that looks like the text they use for Star Wars. I didn't do any of that, but you could. It'd probably be a bubble letter more than anything, so it's probably not going to be great for like a simple engrave, but still doable. So I'm going to say May the 4th, if I can type, be with you. Should that be with you? All right, so that's all my text. Now, it might be too big. I'm going to find out here in a second. But basically, I want to wrap it around this this face here. So the biggest thing about using this as to be able to wrap around is you cannot click the vectorize button. If you click this vectorize button, you break all your text into separate entities, separate lines and arcs. We need it all grouped together. So I'm just going to hit OK and cancel out. Now, this is where it could be a little funky. I would like it to wrap all the way around, and I'm wondering if I shouldn't. Let me see real quick. Let's do a cleanup optimize. Just going to see if I can rebuild these. All right, so I rebuilt this arc into a single piece. And so now I'm going to go to text. I'm going to say fit text to a curve. The text I'd like to fit is this. And the curve, I'm just going to hold shift and pick this geometry here. So we'll see that puts it on the inside, but I want to reverse the direction of that chain, which it apparently doesn't let me do. Yeah, there we go. Reverse it. So there it is like that, but that's not the way I wanted my text to come out. So let me try a different curve to use. Let's try and hold shift and pick this thing. Curve's too short. That's what I figured would happen. Can I do a distance from the path, and will that curve still be too short? Whoops, 0.25. Is that still? Curve's too short. Okay, fine. Let me do, that's about, what, 4 inches, about 4 inches long, almost exact. So what is that? If I was to do 4 divided by 3.14159, so 1.27 diameter would be there. Let me see that real quick. Let me just say my diameter is 1.25. All right, let's see if that does it. So we'll go text, fit text to a curve. Might not be enough, but we'll find out. That's our text. There's our curve that I want to use. Too short. Okay, so I'll go a little bit bigger. I get it. I'm trying to cancel. So there was that arc, and that was, what did I do for that one? I don't remember. What did we do? We came up with 1.27. I'm going to go 2-inch diameter right here and hit OK. Oh, wow, that was a big difference. What is it? I'll do 1.5 for the diameter. Yeah, let's try 1.5. 0.5. All right, that one should work. If we look at the length of that chain, 4.7. So that should be enough to fit it. And now we'll try our text, fit text to a curve. Distance from the path for now, we're going to put at 0. Pick the text, pick the shape. Reverse the direction of it. Come on. There we go. May the 4th be with you. And then for our distance from the path, we can actually use a negative value here. So we could put a minus, 0.0625 or something. And that's just going to kind of shift those letters in, something like that. Can I go even smaller? Let's do minus 0.125. Hey, that looks pretty good. Oh, it's raining. All right, good. Move text from the start. Yeah, we could shift it, I believe. Let's do middle. What's that look like? Let's do end. What's that look like? Shift it around 1 inch. Ooh, that doesn't work. Zero that out. So I guess it doesn't matter where it comes out. So I'll hit OK on that, and there is our text. So now I'm just going to get rid of the arcs that are on here. And that should be the text that we want on the front face of this little guy. And so now we'll go in and we'll set up a tool for that. We'll go tool crib. I'll go position 10, add from the library. It's going to be we'll do a VDI. And I want a face milling adapter. Is that the one I want? Yeah, right there. So there it is. And then from that, I'll just go in and add a tool from our mill. it's going to be a V tool, and I'll do something like a 1/8 inch 60 degree. Hit OK, and then make sure it's facing the right way. Honestly, to this day, that's the biggest problem I run into. Also, let's look at that tool. Let me delete that real quick. Let me add a tool. I want to go back to that V tool. It looked extremely short just now, sticking out of there. And I do need it to kind of reach through something. Flute length, overall length is 1.5 inches, should be fine. All right. All right, pick it again. It seems excessively short, though. But I guess if that's 1.5, that's 1.5, right? All right, so there's our little V tool. The tool path I'm going to use is going to be we'll do that. We're going to go with a mill feature. I'm going to do a mill 3-axis wireframe. Pick my geometry. We're going to go right on the text layer. Pick the text. Oh, I got to explode it first. Hold on. Let me try that. Utilities, explode. I'm going to explode all that. Hit OK. Cancel out. Try it again. Mill features, 3-axis wireframe. Select geometry. We're going to pick that. That looks better. The top of feature, I do need to go in and pick that edge right there so it knows, how far to start down. And then we're going to use the engrave rough. I'm not going to put a finish pass on it. It's just kind of a chase pass anyway. Depending on your machine, longhand code, auto y-axis, or polar interpolation. I'm going to go with just longhand for now. Try and keep the y-axis out of it if I can. But you may need to. And then I'm going to go to the tool crib, find my V tool. Okay. And step distance. So this is where we define how deep we want to cut that geometry into the face of the model. But it's not like your normal depth of cuts that you normally set up. So like a 2-axis, you say, I want to go a 1/2 inch deep. It knows it's a 1/2 inch deep. It's asking you how many passes you want to use to get to that 1/2 inch deep. With this one, what you're going to do is whatever distance you have here, you're going to multiply by your number of cuts. And so if you want to go, I'm going to go 50 thousandths deep. Or we'll do, what do we got? Stick out, flute length. We'll go 100 thousandths deep. So if I was to say 0.1, a lot of people get confused with this one then because they go, I want to do 100 thousandths and I want to do it in 2 passes. What we're seeing now is a 200 thousandths total depth of cut. It's going to do 2 passes each at 100 thousandths. So whenever you're doing your distances for this engrave rough, multiply these two together. So I'm going to go with 50 thou times 2, and we're going to cut from the geometry. By setting our top of job to right down there, we're essentially telling it that the text is down there. So it's going to cut from the text into the part, 100 thousandths. I should have enough meat there. We'll find out. And I use this one for all of my engraving, even if it's just 2-axis, just because I like it. And that didn't change the top of feature, though. Pick top. Yeah, the top's there. All right, so I'm just going to use this value here. Let me copy this, cancel out. And I'm just going to take that text and I'm going to sync it down because it didn't work. So utilities, translate. I'm going to go ahead and do this in Z because I copied that value. I'm going to grab that text, hit OK, cancel out. And then finally, we'll just go in, reselect the old geometry so it learns the new position, recompute the toolpath. So there it is. I can already tell you we're going to have some collisions. So we need to go in here and set our clearance or our rapid plane to higher than this number right here. Usually the way I do it, because I always like to have 200 thousandths, you take that number and you add it to this. So plus 0.3937. And that'll ensure that I'm 200 thousandths in front of my part when I do my moves. So I'll hit compute. And you'll see now those rapids will be over it. And again, they should be over it by about 200,000. So wasted a little time, maybe pick geometry different. I don't know. But there it is. So now what we can do is take that guy and we'll move it up to, we'll do it before the cutoff. We'll just switch it with the cutoff. So now we'll do that engrave and then the cutoff. So give it a save before you start your simulation. Every single time, save before you start your simulation. All right, and yeah, right here, coming in. Let's get down to, we're going to look for our 3-axis wireframe. So right down here, or 3D engrave rough is what it's called. And this one should, let's turn on the machine mode. I want to get a decent view of this thing, but it's tough because the tool might get in the way. But all right, so slow it down a little, run. This is the worst part. You slow it down, but then the stupid turret takes forever to get to position. So you're waiting for that. And then as soon as it starts running toolpaths, it's fast again. It runs them like crazy. Come on, you can do it. Should be coming in here shortly. Yeah, there we go. All right, that's what I wanted to see. So this should be spinning around. I don't know where this toolpath, what this toolpath over here is saying it's doing, but there it is. We should have enough. Ooh, we might be going way too deep on that. That looks like we are. All right, 20 thousandths is probably fine. Let's go edit this. Let's just do a 20 thou in one pass, compute, and we'll just go ahead and restart the simulation real quick. This should be a bit nicer this time. Oh, man, didn't mean to hit the cutoff. Hold on. My mistake. All right, there we go. So now we'll go ahead and run it. I don't know why it's jumping around so much. It didn't pick any sort of direction to go with on that, but oh, and then we have a cutoff happening. So the part's spinning during the cutoff. That's why the geometry just disappeared. We have to wait for it to finish, and there it is. May the 4th be with you. Man, it looks so crappy. Hold on, I'm letting it kind of clean up. That's looking better. All right. There it is. So fun little project. It was just something we thought would be fun for 4th of May. I doubt anyone's going to run this. If you guys want to, you can. Absolutely. I'll even send you the file if you're interested. Otherwise, yeah, just a fun little project. I got the file off of GrabCAD. Didn't have to repair too much. It was a pretty decent model, but yeah, there it is. So a lightsaber. There's still more detail. Like I didn't cut these pockets in. I didn't feel like setting up a tiny tool to do it. These little sections right here, these little things, I don't know. For me, I'd probably end up machining them out and putting little something standing in there. Or I'd have to go in and get a real tiny tool that goes in there, which I didn't feel like doing all that. So there it is. Goofy little project, but fun stuff. So let me give that a save.